What I'd like to do now is talk about alternative energy. And during the 50th anniversary of the crash at Corona, I met Colonel Philip Corso. And during this conversation, I expressed to Colonel Corso I was interested in alternative energy. And he said, I have some information that I'd like for the governor of the state of New Mexico to have. So I passed a letter from Colonel Corso to the Governor Johnson. And what this letter contained was that in the mid-1950s, Los Alamos National Laboratories came to his base called Red Sands near Carrizosa, New Mexico. They dug a hole about 30 feet deep and buried a 6-ton generator. And this generator was to produce electricity for 25 to 30 years with no maintenance. And that got my attention. Also, in this letter, Colonel Corso made a statement here I'd like to read to you. At the end of the letter he wrote, I write all this for the governor. It is only fitting since Trinity Site is in New Mexico, the crash of the UFO was in New Mexico, it all began in your state, and it is only logical that the New World begin in New Mexico. And what he meant by New World is unlimited energy. I have been very, very involved since that time, actually before that time, but anyway, a few years back I also met Colonel Tom Bearden, and had been following his work now for about 10 years and what we're talking about there is energy from the vacuum. That is just really, really important because that's where energy comes from the vacuum. What I'd like to do is dedicate the rest of my talk to Colonel Philip Corso and Dr. Tom Bearden. They've really helped me out in my life. Dr. Tom Bearden had a provisional patent application for a heat amplification process. And he placed this provisional patent application onto the internet and gave it to the world. And what I'd like to do is go through this heat amplification process with you and describe of how easy it is to solve our heat problem. It will take some engineering and acceptance by the different disciplines, electrical engineering, physics, chemical engineering, and things like that. But here goes on how we can make heat rather easily. I'm going to start at the center of this diagram here at number 7. What that is an infrared light tube. And what that does, it takes normal everyday electricity called pointing going into this infrared light tube, coming out and going over here at number 9 where it enters number 10. Number 10 is a nano-sized particle. A nano is 1/1,000,000th of a meter. And once this nano-sized particle starts vibrating, it attracts in from this huge Heaviside component here, diverge in this number 11, and we put 1 part heat in from pointing, and it'll divert 18 times more energy in from Heaviside, and we'll come out with 18 times more energy than we started with. It's just that easy, the principle of amplification of the heat. Now what we need to do is discuss where does the pointing and the Heaviside come from. And where it does come from is over here on the left hand side at 1. 1 is a dipole. And a dipole consists of an electron, which is negative down here on the southern tip, and a bubble up here, which is positive on the north. And they're separated by a little bit of distance. And by having it at a small distance, what it does It brings in energy from the vacuum as number 2 here. And what this energy in the vacuum is, it's virtual. You can't measure it, you can't see it, you can't use it. Basically, it doesn't exist, but it has to exist because you get something out, so you have to have something in. So what happens is, here at number 2, these virtual particles line up and go inside of this dipole. And inside of that dipole, the virtual particles are consolidated until they are kicked out as usable photons. And these photons are, you can see them, you can measure them, and you can use them. And that's what we use as energy. And also back to the dipole, which is also known as a magnet, there are about 200 different components coming out of that magnet. And so far, the scientists have studied about 100 components. They've actually got names for roughly 50 components, but today we're only going to be talking about 2 of the components. One is the tiny little pointing compound, which is basically flat. It's just flat. And it's fuzzy, comes apart, they can tap it, they can control it, and they can use it. Where the energy really and truly is in the Heaviside component, and the Heaviside component is wrapped around the pointing, and it's much, much bigger. The Heaviside is much, much bigger than the pointing. But the Heaviside does not like to be caught. There is actually another force on the outside of Heaviside that keeps it from coming apart. And back in 1892, the electrical engineers at that time chose not to use Heaviside. They could not figure out where it came from, they didn't know how to control it, they couldn't use it, so they said, being it doesn't want to be used, we won't use it. We still are not using it today. That's the problem. We need to use Heaviside. And this diagram here shows that we do use Heaviside. Because once Heaviside is kicked out of this magnet, it comes along here, and normally, if this was just a normal copper plate there, Heaviside would just go along and just go back out into space. But with that vibrating nano-sized particle, Heaviside comes along, some of it is diverted into here, into this vibrating nano-sized particle, and then it's kicked out as heat. And that's usable heat. And that's what we got going. And that's all there is to that.